Let's take a look at how we can use a couple of functions in Google Sheets to calculate duration. So duration measures the price sensitivity of a bond when interest rates change. So there are two calculations we need to do. The first is Macaulay duration, named after Frederick Macaulay, who came up with this formula. And what it is, it's the average amount of time it takes to get your money back from the bond. So if it's a coupon bond, that is, it makes periodic interest payments annually or semi-annually, you don't have to wait the full maturity to get your money because you get some of it every year in interest. So the example I have here is it's a 10-year bond. And if it's paying a coupon, you'll get some of your money back in year 1, some of your money in year 2. Now the bulk of your money will be in year 10 when you get back the maturity value, but you won't be waiting 10 years to get your money. If you have a zero coupon bond, those are bonds that sell at a discount, don't make any interest payments each year, and you simply get back the par value when they mature. There, the duration is going to equal the term to maturity. So how do you do the calculation? Well, here you have the present value of cash flow in time period T divided by the price of the bond. If you summed up all these present values of cash flows from year 1 to year 10 in my example, you would get the price of the bond. So really, this, if you ignore the T, is the fraction of the bond's price that you get in year 1. For 2, it's the fraction of the bond's price you get in year 2. And then we multiply it by each year. So 1 times the fraction you get in year 1 plus 2 times the fraction you get in year 2, etc., etc. And that gives us the average amount of time it takes to get your money back. Once you've calculated Macaulay duration, we want to calculate modified duration, which is Macaulay duration divided by 1 plus the yield divided by the number of coupon payments that are made each year. So in our example, we're just going to use 1, but oftentimes bonds pay semi-annually or twice a year. So I have an example here. Settlement is March 1st of 2023, maturity March 1st of 2033, so 10-year bond, has a coupon rate of 7%, a yield of 6.7%, a redemption value of 100. You have to use 100 in this function, okay? So you can't put in 1,000 as a redemption value. It does it for 100. And the frequency is the number of interest payments each year. There's also one other function or one other argument you can put in. I'll show you when I use the function. So over here I did it the long way. I calculated the cash flow. What's the cash flow? The cash flow is going to be equal to the coupon rate times the redemption value. 7% times 100, $7. And in that last year you get the $7 and you get back the redemption value. The present value, then I calculated the present value of the cash flow. So present value of the cash flow is simply going to be this cash flow divided by 1 plus the interest rate raised to the year power. So in this case, year 1. In this case, it would be raised to the second power, etc. If I sum these up, I get the price of the bond. So over here, if you look at this toolbar, if you don't see anything here, you hit these dots here, and there's a big sigma. If you hit it, there's some functions. So we can sum these, and we can just highlight these cells. And I'm at, I want to be at B17, I believe. And hit enter. And I get $102.13, which makes sense. If the interest rate went down, the bond price should be above the redemption value or the par or face value. I'm also going to sum up these. So again, I'll just use that summation function. and I get 770.51. So the Macaulay duration would be this, right? This right here is the numerator here, and then we divide by the price of the bond. So I'm going to say equals this divided by this, and I get 7.544. So that's about the average amount of time you wait to get your money, right? Most of the money comes in year 10, so it's going to be close to 10, but you're getting some money in year 1, you're getting some money in year 2, etc. So it's going to bring the average down to less than 10. Modified duration is going to be Macaulay duration divided by 1 plus this yield of 6.7, and we get 7.07. So you can see how it's done. It's not really that bad, but there's actually functions in Google Sheets that will do this for you. So the duration function, and if you don't have this information here, so nothing comes up, just hit that question mark, and it'll tell you in what order to put the arguments. Settlement is the first argument, maturity is the second, the rate, okay, now I'm kind of covered up, so I'm just going to have to type this in myself. We need the yield, which is in B10, and we need the frequency, which is in B12. And then there's also a day count convention, which we're not going to worry about. If you don't put anything in, it's going to use a 360-day year and a 30-day month count. So let's hit enter, and we get the same answer, 7.544. And there's also an MDuration function. And again, we put in the same arguments. And we should get the same thing we calculated before. 7.07. So much easier to do it this way than to have to do it longhand. So might as well take advantage of the functions in Google Sheets that does this for you.